Yeah, ladies and gentlemen, a warm welcome and official hello from my side. My name is Bastian Brenken. I will be moderating through this web seminar Wednesday. You probably know me from the one or other web seminar that we did in the past. We have an exciting program today. Fabian, Nowacki and Axel Reinsch will present Calcbond to you, a new platform to design joints, adhesive joints. So before we start with this presentation, and I think also a live demo showing you the platform, I will briefly explain the structure of this web seminar. As usual, we will have about 30 minutes presentation, plus minus 5 minutes. We are not very strict there. And after that, you have the opportunity to ask your question, to engage in a discussion. We will have a Q&A session where you can raise your hand and unmute your microphone to answer ask, or also already during the presentation you can post your questions in the chat. With that, it's my pleasure to hand over the word to the two gentlemen. Have fun, enjoy, and you enjoy the presentation.
Yes.
Yeah, thanks very much.
Yeah, thank you, Bastian. Yeah, welcome from us as well. My name is Axel Reinsch. I'm CEO of AR Engineers. Next to me is Fabian Nowacki, the head of engineering here at AR Engineers. And we present Calcbond to you today with the special focus on our launch of the software next week on the 14th of June 2022. So let's hop into the presentation, right? First of all, I want to introduce you to AR Engineers and what we're doing here, and give you a little tour on why did we start to develop Calcbond. From there, I will give you a theoretical idea of what Calcbond is, what we do, the main product areas, and then Fabian will take over and show you the platform on a live demo. So yeah, as I said, my name is Axel Reinsch. I founded AR Engineers in 2013, we moved into a GmbH, and our focus is the lightweight industries. We are a company that designs and works with lightweight materials, mainly composites. I would say 95%. Of course, we have always metal parts in our assemblies, but that is mainly for joining parts, and that brought us as well to the adhesive industry. Our tools that we use is, of course, the Fea to do calculations. Of course, we do analytical calculations as well, but yeah, our main tool is the finite element analysis functionalities that we use. We have some R&D project that I will not go more into detail here because Fabian will have a few words about that. We do production supervision especially for the wind industry, where we have people in the production of larger companies all the time to supervise the production. And one of the latest and newest fields that we work on is actually the software development itself. That came because we're actually doing that all the time. But has never been the focus. It was in the background that we working when we do Fea work, that we programmed our own functionalities within the projects. But today we brought that more upfront because our clients may want to use these functionalities by themselves. And this combination of the new challenges we have in the industry, that we have to join different materials together, that we want to bring functionalities to our clients, brought us to the fact that, and of course that we want to do faster than in the past, because everything is tighter. We have the budget size goes smaller, the time that we have available for a project is on pressure. Brought us to the fact that we need to have advanced method, advanced functionalities to work sufficient. And that actually brought us to Calcbond. But first of all, I switch over to Fabian for our R&D projects.
Good morning from me as well. So in parallel to our industry projects and the new software development branch, considering Calcbond, we always also focus on staying on top of things in terms of new technologies in the lightweight industry. And this is why we engaged in several different cooperation projects for publicly funded R&D. As you can see here, we have the big project High Five, which has been going on since May 2020 now, where we develop and support the development of new innovative joining techniques between glass fiber reinforced plastics and metal structures with the Faust technology, originally developed by HiConnect here in Hamburg. And there we work in the simulation field and the numerical characterization of the new materials that are used there. In the second project, Fantastic, we work with the Institut für Verbundwerkstoffe in Kaiserslautern, considering the characterization and generation of life prediction models for adhesive joints, which also serves as a source for generating more knowledge, more in-depth knowledge, better models to also use in Calcbond and our further industry projects for clients. And the third project we engage in also in cooperation with lots of different companies from the northern German industry is E2Mut, which focuses on urban electric mobility on the water. So basically it's about a largely set infrastructure mobility study where we are responsible for developing concepts of electrically driven surface vessels, small surface vessels, supported by hydrofoils built of carbon fiber reinforced plastics. And so working in these three projects with lots of really strong industry partners and research partners, we're able to always stay at the forefront of innovative technologies and R&D knowledge, which we can use and benefit from also for Calcbond, but also for other projects.
Yeah, and now what's our mission with Calcbond? Calcbond is a full ecosystem that contains three different product areas. The first one is the material database, and that's one of the major points that we carried out with Calcbond. With Calcbond, you get different material data from different material manufacturers in your account, so you can use them for further work, whether it's on Calcbond or actually offline. The Analytical Calculations is another product area that's of course based on the database. You can either put in your own values or use the material data that's coming from the manufacturers and do analytical calculations for adhesive joints. The third and major product area is the automated FEA. Within the automated FEA, you get predefined, standardized joint geometries or joint scenarios where you can define your system and run automated FEA and get results within a very short time. So what do we want to do with that? We want to simplify the use of adhesives and provide a reliable solution for the adhesive joint designs for our users. So we shorten the time of getting the first results, getting the first idea of the joint geometry, whether it's strong enough or sufficient for the purpose that's where it's going to be used. Let's go a little bit more into detail before we jump on the platform itself. As I said, first of all, the material database as a first product area, as on that picture on the left, on the right side, where you get the advantage that you have an easy click access. You can browse through different materials, through different material suppliers, and see the different values, study and select the adhesives for your applications. And from there, you can go directly into the first analytical calculation and use that material that you have studied and decided to go with. The next step is then the analytical calculation itself. So here you are, of course, restricted to what's actually possible to define in an analytical process, because this is quite simplified geometries, as you can see on the pictures on the right. But on the other hand, it's very fast, it's very straightforward. You can retrieve results from the material database, as I said. You can evaluate the results within seconds because it's a very fast and straightforward process. You get a very fast and first idea of your adhesive joint. If that's not enough, because your system is more complex, you can of course use the automated FEA. Important is, of course, as I said in the beginning, that you still have to do a simplification of your adhesive joint, but from there you can still use a 3D geometry that's predefined on our platform, and you go with that. You can take the material data from our database, perform design analysis of a concrete adhesive part. You can get stress and stiffness evaluation from the 3D FEA. And of course, and that's as well valid for the analytical calculation, we provide an automated documentation, and you get straight away your document on that platform. Yeah, I think that's the main thing that we can say from the presentation. I think from here I move on to Fabian, and he will give you a tour on the platform itself.
Yeah, thanks very much. So let's dive into Calcbond itself to give you a little sneak peek of what is awaiting you after the launch next week. So here we are right now in the material cards module of the toolbox, where you have access to data sets of different renowned suppliers, for example, Huntsman or also Sika, who cooperate with us and provide a basic range of their most popular products used in the industry. And you can then select a number of different products to view the data. So you will have access to view the basic technical data, which you might already also know from the typical product data sheets, but you will also have access to the more advanced engineering data, which will load in a second. So you will here have, for example, the Sika Power 1277 product, which provides basic information about the product, basic application information, and physical properties you might need to know beside the calculation part of your project. And then on the right side, you have your more advanced data about engineering properties, which are also, for example, temperature dependent. So we want to provide mechanical properties that are dependent of the service temperature. So the data that's been provided within the database is has been tested under different environmental conditions, so under different testing temperatures to account for the different elastic or elastoplastic behavior of the adhesive. For example, compared between a 0-degree testing environment and a, for example, 60-degree testing environment, which has a big impact on the mechanical performance. And also you can see typical test curves, for example, from a tensile test at room temperature here, to get an idea of how the elastic stress strain curve or elastic plastic stress strain curve behaves, and for you to get an idea if you are working with a highly brittle adhesive or a more modified, toughened ductile adhesive. And if you're happy with what you have, you can directly jump into your analytical calculation from here, as Axel mentioned already before, by clicking on this button here, Submit to Join Calculation. If you click here, the tool will guide you to the analytical tool in a second, and will take all the basic calculation data you need to perform your analytical solution with it. So if you decide to calculate, for example, your standard single lab rectangular joint, for example, to imitate a laboratory test, you can use this load case, and you see here you have your input wizard with the geometry parameters, which you can define however you like. We can increase the overlap length if we want. And as you see, your product that you've just chosen in the material card module is pre-selected here in the dropdown. You can always also change if you want, but everything you need to put in is already predefined for you. And the only thing you can, of course, change is your adhesive layer thickness if you have a design requirement, which varies from the optimum adhesive layer thickness of the product, for example. We can then move on to the adherent materials. Here you can define isotropic adherents. They can be dissimilar, so you can join a steel adherent of 5 mm thickness to a different steel alloy or aluminum alloy with a higher thickness, for example, 6.5, and choose this for your calculation. You could also decide to switch over one adherent or both adherents to composites. So we have a basic composite laminate editor here, where you can change your stack up sequence or your distribution of different orientations of layers. So if you don't want to calculate a 100% unidirectional laminate, you can say, okay, let's do a 50-50 laminate setup with 90-degree plies also, and then you'll get your effective engineering data, which is then submitted to the calculation. So moving on, in the last stage of the setup, you can define your loads. So here, as illustrated, you would be able to load your joint at the free end of the second adherent with a horizontal tensile force, a vertical peel force, or a peel moment. And you can choose these individually or superpose them. And if you want to take away one force component, you just put in a 0. And then you're ready to go and can start your calculation. Oh, I'm sorry, that's a typical show error now. And if you want to view your results, you can see here your input overview of your forces. This is now for a different application for a T-peel joint. And here you have your results, your stress plot. So here you see the distribution of the most important stress components in your adhesive layer. So here you'll see along the bond line, the distribution of peel stresses in blue and shear stresses in the adhesive layer. And also on the right side, you would see the failure criteria. So the tool automatically calculates reserve factors or adverse reserve factors from the different stress components to evaluate the overall strength or reserve of your adhesive material itself. And you can save the calculation if you like. As you've seen, I've already did this for a predefined project. And then you can download the PDF report, which provides information for your calculation for everything that you've just done online, but now in a PDF format, which you can save offline, print out, share with colleagues, and so on. So here you have all the information about your application, the geometric parameters, the material parameters, the loading scenario, and your adhesive material. In this case, it's a highly brittle aldehyde material. And also you see an overview of your analytical stress results, the stress plots, and your tabular data. Also along with explanatory texts for you to help understand the or interpret the results correctly. If you're not a specialist in stress engineering, for example, but still want to use this tool, you will have helper descriptions to help you understand and grasp the results more and use them for further steps in your project. And here on the last page, you'll get a collection of important links to the platform itself. For example, we have a wiki section where you'll have access to further information about the toolbox, but also about the theory behind everything and how the tool works, how the calculations work, and so on. And you get a unique link to your project here, which you can also access via the PDF report or share with colleagues, as well as this QR code. Okay, and now moving on to the most sophisticated feature here, as Axel also mentioned in the presentation, the automated Fea module, which provides a set of standardized use cases. For example, you'll be able to perform numerical 3D simulations of bonded profiles as seen here, or also coaxial bonds with different tubes. You can simulate fastener to plate bonding or to sandwich plate bonding also. And for example, also stiffener bonding scenarios where you have plates with stiffener elements that are not directly loaded, but you still have an impact on the adhesive bond by the deformation of the plate, for example. So to dive into an example, I'll select the use case number 2, the beam bonding. And here you can see you have a pretty simplified input generation deck for the most important parameters that are needed for the numerical solution to proceed. Here you can define your geometric parameters of the 2 profiles, so the 2 adherents basically. You can control the length, the width, the thicknesses of the different sections, and of course also the adhesive layer thickness itself. Again, you can choose different engineering materials for the adherents. You could also set up a different bond line fillet geometry if you want to analyze influences of different edge fillets. And you can also, of course, choose different adhesive materials, but here as well, we have predefined our selection from the material card database. And then also, quite interesting to know, you can set up different analysis options. For example, if you want to put up your own customized knockdown or safety factors to the material properties or to the loads, you can do this here if you directly want to incorporate that in your solution and not having to do this by hand afterwards. And you can set up your loading speed to account for the different strain rate dependent mechanical behavior of the adhesive material, which is, for example, very important to account for with highly flexible adhesives. And then you have your loading definitions. So here you again have different types of typical loads, which you can put up in superposition or separately as you like. And also you can put up a temperature load. So this will also incorporate a temperature rise, for example, here to 45 degrees Celsius as a boundary condition, which accounts for the thermal expansion of the adherents and also of the adhesive material, which also induces additional stresses, of course. And then you can define your boundary conditions of the joint itself. So you could choose to have a doubly fixed support of the beam for a very stiff boundary condition, or you could change that to standard supports or doubly hinged supports if you don't want to fix rotations, for example, of the beam. Then you submit your request and you get a notification that the request has been sent to our server and will be processed immediately. And within a couple of minutes, you can return to the tool and you're able to view the results basically. So you can push the button here and view the numerical solution results for your joint. As you can see, you'll get a in-depth overview of your deformation, joint deformation, also the adherent stress distribution and the stress distribution or strain distribution also in the adhesive layer. And on the bottom, you'll have an overview of first the input properties again, but then also your results in tabular form. So your maximum values, deformation, beam stresses, adhesive stresses, reserve factors. If you've put in safety factors, they will be accounted for here also. And that way you have all the most important information about your application on the tool itself. And you can also always download the Fea report in a PDF format as well, similar to the analytical report. And this would look like this. So you have a similar layout with an overview of your load case definition here, your loading scenario, the boundary conditions, your product data. So here you'll always also have a link to the product from the respective supplier. And you'll see which information has been sent to the solver, basically to the server for layer thickness, engineering data, and so on. And then again, what you've just seen online in the platform will also be displayed in the report itself. So your most important stress plots, the maximum values, and deformation plots also. Which makes it a compact but still complete document for you to work with and to give to your colleagues, superiors, which supports you in, for example, design evaluation, decision-making of joint designs, and can also support in certification processes for joint designs of bigger structures, for example. And then again, on the last page, as already seen, you'll have the most important links to our tool, to the wiki, and your calculation project link as well. Okay, that is, that's it from my side for the features here. Then I'll hand over to Axel. Yes, for the last bit of the presentation.
Yeah, one of the, of course, important part is how do we provide the service to our clients or to the users. We have in general 3 different plans planned, starting next week on the 14th of June. The first and simplest version is the standard user. If I click on the more detailed list here, you can see that the standard user has basically all functionalities included, but in a smaller way. So we plan that the analytical tool can be used as much as anyone wants. So you can calculate almost the entire time, all the time, as much as you want. For the FEA service, for the standard user, there's only 1 calculation a month, but you can always book more calculations on top. This may be interesting if you have a lot of different standard joints to be calculated over the year. But for FEA calculations there, you can't really plan with that. It may come up or may not, and then you can book extra services on top. If you think you will have more FEA joints to be calculated, you can jump on the advanced plan. Here you have 5 FEA solution included, and the rest is basically the same. You can run the analytical tool as much as you want. As well, the PDF report is limited to 5 reports in the standard version and 15 reports in the advanced subscription plan. The pro user will be even larger. For these numbers, you can have 25 reports every month and 15 FEA solutions every month. We plan to have an optimization and design exploration tool, which will not go online next week, but towards let's say next year, end of this year, and that optimizer can be used starting from the advanced plan, and of course even more on the pro plan. You can basically book these 3 different subscription plans either for 1 month, for 6 months, or for 12 months. Of course, for the 12 months, you will have the best rates. And if you just want it for 1 month, this is the most expensive version, so to speak. But if you know that's just coming up for 1 month or a very short time, and then you will not have to enter your data again, or the material data, or your your project data that you have, as Fabian shown you, saved on the My Calculation page. 1 month may be enough. Yeah, and that's how we plan it. So I think it's very, very efficient if you want to run FEA or analytical joint calculations and get results for these challenges in a very short time, in a very economical way, because you don't have to run this all by yourself. You just use the predefined systems and organize yourself within Calcbond. Yeah, and then that's from my side. Thanks for listening, and if you've got questions, feel free to ask.